My name is Joe Fortenbaugh, and I'm the CEO and co-founder of Actinic, and we are printing off-the-shelf resins and solving the material disconnect between 3D printing and industry. So at the moment, there's a big disconnect between the materials that are available for industry and those that are available for 3D printing. So in general, thermoset resins like polyurethanes, silicones, epoxies, and more make up 90% of the polymers that industry uses, whereas 3D printing only has less than 1% of those materials available for 3D printing. So we can print real off-the-shelf resins. So we have resins from Dow, Los Alamos, Smooth-On, NuSil, just for our silicones. And we can take these commercial off-the-shelf resins, reformulate them so we're not changing the chemistry, and we can print them on commercially available hardware. So we're working with O&L on this project, and we're designing the technology to be able to work on the BAM 3D printer at the manufacturing demonstration facility. So the benefit of our technology is that there's no fixed cost and there's a quick turnaround. So for traditional injection molding technologies, it takes months for a product to go from initial workup to the final product in your hand. Whereas with 3D printing, we can turn around a new product in 3 to 5 days, which is 90% faster and has 50% cost savings. For example, we have a grommet from Caterpillar that we're printing that is a low volume but highly needed part for the construction industry. So there's a range of applications for our first material, which is a silicone. So we have seals, gaskets, and grommets, custom fitting respirators for chemical warfare for the Army and medical devices, radiation shielding for the outside of aircraft and aerospace technology, as well as prosthetics and orthopedics for custom medical applications. So Actinic really positions itself against the competitors by being able to print a large number of materials and having materials that are off-the-shelf resins. So most 3D printing materials are very chemically specialized, whereas we can take any commercial off-the-shelf resin that's thermally cured, add our secret sauce to that, and then be able to turn that around and be able to 3D print. So up to this point, we've raised almost $1 million in non-dilutive funding from Penn State, the NSF, Department of Energy, the U.S. Army, and the Oak Ridge National Lab. We've just applied for follow-on grants, SBIR grants from the U.S. Air Force and the NSF, and we're seeking a convertible note for $500,000 in the next year, and then in 2023 we plan to launch our production model. So I'd like to thank my team and advisory board for helping me get to this point. I'd also like to thank Innovation Crossroads and the National Lab for giving me the opportunity to participate in this Innovation Crossroads Fellowship, and I look forward to seeing what the future holds for myself and the other technologies.